us again, then I will accept. Okay, recording has started. Probably she wasn't using MMU mail. Okay, guys and girls, good evening. This is our second workshop for SPSS. We're going to continue from where we left last week. So if you have the slide from last week, you can continue. Let's see where we stopped. Okay, so we are looking into, we have a questionnaire that we are following, and also last Friday, we looked at how to look at SPSS in terms of looking at its data view and also variable view. We saw the different views in data and variable view. We also saw how to insert your questionnaire into SPSS, which is like the most important step, right, at the beginning. How do we convert your questionnaire, sort of programming it into SPSS? So mainly, you know that SPSS has two windows, data view and variable view. Variable view is where we insert our questions and with labeling. And the important part here is, most importantly, is the values. You determine your values according to your questionnaire. So we also saw that you can't actually do SPSS analysis without having your questionnaire. All right, without having your questionnaire, you need to have your questionnaire because the questionnaire will determine everything. Okay, so all the things that you insert here will depend on the questionnaire. So that's why if you notice that every time I do the SPSS class, first thing I will do is I will open my questionnaire first. All right, open the questionnaire and keep one side, because you will refer to your questionnaire a lot when you're doing your research, when you're doing SPSS, because SPSS depends on the questionnaire. So always have your questionnaire beside you when you're doing it. And then secondly, you have your data. Right, so let me just see the slide again, see where we stopped. So we have done some practice. We have inserted the entire questionnaire inside. And I think we also did the descriptive statistics. Right? So we have done this as well, analyzing descriptive statistics and frequency. And we played around with the system and got a few different tables, especially like finding out descriptives of people. So you can do descriptive statistics for all demographic information, which is whatever questions that you find in the section A of the questionnaire. Normally you can do descriptive and frequency analysis with them. Okay. So you can also do cross-tabulation. I will show you what is cross-tabulation today before we go to our second analysis. So we are following this analysis practice. So we did this last week. So I want to do the rest today. We should be able to do all of it today. So now let us open our SPSS. So opening SPSS, you know, if you are outside of MMU and you're trying to access the license for the software, you need to first open your Cisco VPN. I think you know that. The VPN is somewhere here, right? So the VPN, so please ensure that you're already connected to your VPN. Before, see, the VPN must be connected to vpn.mmu.edu.my, and then choose yourself as a student and then enter your password, and then your VPN is ready. So without VPN, you cannot proceed. You need your VPN. Once the VPN is running, you can then open your SPSS. Okay, so it may take 20-30 seconds to open because it's a big program, and then you are opening it remotely. So that will further probably delay it. But if you're doing it on your own, I've noticed, I've tried it last week on my own. If I'm not in the Google Meet, it's actually pretty fast. Maybe it's lagging a bit now because, you know, there are so many of us who are watching it, and then at the same time, we are connecting to VPN. Otherwise, it's quite fast. So SPSS will open. Okay, so once the system open, you can open the data file, and you know your data file, right? You have the data file here. You also have an option of double clicking the data file. The data file is .sav. all SPSS data file is .sav. So you can double click from here or you can open from here. So once you open it, it's all here. It will appear here. So you know already this one, which is a variable view. All the questions are here. And then data view is where you insert all the data. So pretty straightforward. You have your data now. So let's do an analysis. So this window, you can always minimize it. This is your output window. So I hope everybody is fine and everybody can hear me clearly. If there's any issue, please chat, let me know. So I'll be in the know, because when I maximize SPSS, I can't see your chat unless you speak up, then I can hear you. I will put the volume louder. So in case if any of you say something, then I will know. Okay, so we want to do now cross tabulation, right? Cross tabulation is when you put two descriptive variables into together to get some analysis. So for example, you can go to analyze descriptive statistics and choose cross tabulation. And then you can choose two things in your rows and column. For example, you can choose nationality and how often you use the internet. And then it will give you a data that shows cross tabulation. A data that one side has descriptive, another side also descriptive. So the data is more meaningful like this. Right? This is called cross tabulation. So let me show you live how it's done. Go to your data file, just analyze descriptive statistics and choose cross tabulation. This is one way of presenting your data well. Okay, whenever you see your data like this, if you want to see your questions, you can also right-click and change display variable name. And then you display variable name. If you right-click display labels, then now it's displaying the labels. So it's up to you. So for me, I want variable name because it's short for me, easy for me to know. So I'll put display variable name. So let's say I want to know gender, how many male and female, and what is their education level. So I can sort of put gender here, education level here in two columns. If I click OK, I should be able to get an output that shows something like this. So here I can see that male, there are 31 male with high school, 96 male bachelors, 50 male masters, 12 male PhD, and others. And for female, I can see 15 female high school and so on, all the way. So this kind of analysis is very easy to do in SPSS in cross tabulation. So just go to analyze, descriptive, cross, and then you can try maybe gender with something else, maybe gender with income, right? Gender with income, for example. It shows now different income level and then what is the gender distribution. So you can play around with it. Cross tab, you can play around, let's say, I don't want gender now. I want maybe education level versus internet usage, right? People's different education and internet usage, and see whether there's any correlation. Maybe there's an assumption that people who are highly educated will use more internet, but we don't know. So we can see from this cross tabulation. So you can see here from the education level now, high school, bachelor's, master's, PhD, and then you can see how many of them are using the internet. Okay, so you don't really see any pattern here. It looks pretty similar whether they are. It doesn't show any clear distinction whether there is difference. I don't notice a very a pattern or anything. It does. So it does mean that internet usage is not something that is dependent on people's education, which is quite true. You don't have to be highly educated to use internet. Anybody can use internet. It's very easy to use. So maybe that is what this data shows. So this is basically what cross tabulation is when you analyze two things, two variables into one. It's called cross tabulation. So I hope that's clear. So let's move on now to our second analysis, which is computing normality test. So we have done this. So this is done. So we want to do this now, normality test. Conduct normality. So what is normality test? So normality test is to test whether all your variables are distributed normally, all your variables. So in order to do that, first of all, you have to look at your questionnaire again and look at your variables. So now we are already moving into your IVs and DV. So you see your IV, you have knowledge. But in knowledge, you have actually 5 items. And risk perception, you have 5 items as well. So how do you know knowledge is normally distributed or not? You need to first compute knowledge. At the moment, we don't have the variable for knowledge. We only have knowledge 1 until knowledge 5. So what we have to do now is first find the average, find knowledge. So how do we find knowledge is basically we have for all the IVs and DVs, we have the items here. We have people responding here. So what we need to do here is basically to add this item plus this, plus this, plus this, plus this, divide by the total number here, which is 5. So if I add all of this, divide by 5, I can get the average for this. Right? So similarly for risk perception, I will add all these 5 variables, the number, the result, or the average of all these 5, divide by 5, I will get risk perception. So basically that's how we calculate average for each of our IV and DV by combining all the other variables and dividing by total number. So we have to do that first before we can do normality test. So how do we do that? We go to, you can see all the variables are there. Huh? How do we compute variable? There is a formula we can use. We will go to transform, compute variable, and then the window will appear where you can start computing. So before that, I can show you, if you go to your SPSS, you will see that you have knowledge 1 until knowledge 5. Okay, but there is no average column for knowledge. Similar for risk, you have risk 1 until risk 5, but there is no average for risk. Same for trust and for adoption. So we need to find what we call the total column for each of these. So there will be 1 for knowledge, 1 for risk, 1 for trust, and 1 for adoption. So that's what we mean by average column. So how do we do that? We go to transform, compute variable. Okay, transform, compute variable, and this is where we insert our target variable. So for example, for all this knowledge, we want to have 1 that says knowledge. Okay, we want the average for knowledge. So the knowledge now will be equals to, this is a numeric expression. So it will be equals to knowledge 1 plus knowledge 2 plus knowledge 3 plus knowledge 4 plus knowledge 5 divide by 5. So because the division comes later and you have to plus first, it's better to put a bracket first. So this is what I will do. I will put a bracket and then I will put knowledge 1 inside plus knowledge 2 plus knowledge 3 plus knowledge 4 plus knowledge 5. Okay, and then outside the bracket, I will put divide by total number. Here I have 1, 2, 3, 4, 5 columns. So I'll put 5 here. Okay, and then just click OK. So once you click OK, the output window you can minimize. And now if you go to the last row of your variable, you will see there is a new column being created. It's called knowledge. So this column here is 2 decimal point. You can leave it as 2 decimal point because it is calculated. And this column actually is the average of all the 5 in knowledge. So basically now we actually have the data for our questionnaire, which is this. Now we know what is knowledge. Okay, previously we only know what is all this, the items for knowledge. Now we have the average for knowledge, and the average is this. Okay. So what you need to do after this, you do the same. You do now for risk perception, and then you do for trust, and then you do for the DV as well, adoption. So you all can try that on your own. Do you want to try this on your own now? Okay, so knowledge is done. Now you can also do the rest for, you can do for risk, you can do for trust, then you can do for EC adoption. So should I wait for you guys to try it out? Anybody trying it out? Nobody's trying it out? Anybody is still there? Yes, Waiting, trying. Is it working? Yes, Wan Ying, it's working, All done. Good. Very fast. Good, good. So you guys are done then. All right. So then we can continue. Let me continue then. What do you do after that? Okay, so once you have done for knowledge, you do for risk. And then similarly, the risk will appear. But there is a problem here. When you calculate the risk, this average is not correct. Let me tell you why this average is not correct. If this average, remember just now you added all the variables and then divide by 5. But if you do the same for risk, it's not correct because depends on your questionnaire. Let me show you what is the problem with the questionnaire in risk. You can see that the risk perception, this is something very important that they should be aware. The risk perception actually measures how risky people think internet is. So you can see the first one, it says, I am concerned about my information privacy over the internet. Which means if somebody answered 5 here, the person is very, very scared, is very concerned. Right? Let's say I answer 5 here. And then number 2, I am concerned the products do not perform as intended. So if I feel it's very risky, here I will also say it's very high. And then suddenly the third question says, I don't think buying online is risky. Right? So if I answered 5 for this and 5 for this, now I cannot answer 5 or 4 for this question. I will have to answer 2 or 1. Because you can see that all the questions here, question 1, question 2, question 4, I am not comfortable to make online payments. My perception of risk influence my decision. All these 4 questions are actually, if it is high, means the risk perception is high. Except this question, I don't think buying online is risky. If this is high, that means the person's risk perception is low. Okay, so this is what we call a negative statement. It's a negative statement because all the questions is measuring one angle, but this question is measuring the opposite angle. So whenever you have a question like that, you will first have to reverse code this questionnaire. You have to code it reversely before you compute the variables, right? Otherwise, if you add, you will get a wrong answer. So it's called a negative statement, which you need to reverse code. So I'll show you how to do the reverse coding. So you need to reverse code risk 3 because it is a negative statement. Okay, so we need to reverse code. So how do we do this? There is a method here called transform, recode into different variable, and reverse code each answer to the other one. So let me show how we can do it live. Go to a variable, transform, recode into different variable, and we are going to reverse code risk 3 into a new variable, and we're going to call the new variable risk 3 underscore reverse coded. I will do the same label, risk 3 reverse coded. Okay, now what we do now is a bit tricky, but watch closely. Now we have to teach the system how to reverse the coding. So we saw from here, if somebody says 6 here, he will say 1 here, and then 6 here and 6 here. So this question is always the opposite of the other 4. So now we will tell the system to reverse code this to the other way around. That means whenever somebody say 1, we will tell the system to change it to 6. Or somebody say 2, we will ask them to change it to 5. Somebody say 3, we will ask them to change it to 4, and so on. Okay, we will reverse code it so that all are consistently measuring same direction. Okay, so how do we do that? We go to old and new values, and we tell the system if the old value is 1, the new value should be 6. Okay, add. If the old value is 2, the new value should be 5. Add. If the old value is 3, the new value should be 4. And is the same on the other way. If the old value is 4, new value will be 3. Old value is 5, new value will be 2. Because we are reversing the entire coding. Old value is 6, the new value will be 1. Okay, so then the system will reverse all this coding and give you a new column, which later you can add for your when you find your computer variable. Continue, and then just click change. Once you click change, RIS3 will be reverse coded to RIS3 reverse coded. Click change is now done. Okay, all you have to do now is just click OK, and then this new column will appear in your variable. You can see it now. RIS3 reverse coded. And you can see that this will be 2 if the original one is 5. If the original is 2, the new will be 5. Original is 3, new will be 4. Original 5, new will be 2. Original 6, new will be 1. Because it has reversed everything and recoded them. So once you have done this reverse coding, then you can continue with your calculation. Okay, then you can do the calculation and get a new measurement. Okay, and in your new complete variable, you should choose the reverse coded one instead of the old one. So let me show you how to do it live. So I'm going to complete variable, and I'm going to reset this, clear this, and now we're going to calculate risk perception, right? So risk perception. Reception. Okay, I'm going to risk perception as usual, put the bracket, and I will put risk 1 plus risk 2 plus, okay, risk 3, don't choose this, but choose the reverse coded risk, plus risk 4 plus risk 5. And then outside as usual, divide by 5. Okay, so now you have the correct statement. Okay, you are choosing the correct one. They are all in the same direction. Click OK, right? And you will get your risk perception. So just now we have knowledge, now we have risk perception. You have to just do this 2 more times to get your trust and your adoption. So let me do it. So analyze. Sorry, transform, complete variable, cancel, reset. Now we want to do for trust. Trust is equals to trust 1 plus trust 2 plus trust 3 plus trust 4 plus trust 5 divided by 5. Before you do this, please make sure in your questionnaire that all the variables for trust are in the same direction. For example, I trust the information presented. I can trust online business. I trust my decision. I trust the quality. I trust online delivery system. So you can see that they're all in the same direction. That means a person who will answer positively for one will have to answer positively for all. So they are all in the same direction. There is no negative statement here. So you don't have to reverse code. So now I have my trust, I have my risk, I have my knowledge. I just need my DB now. What is my DB? So I know my IB is knowledge, risk, and trust. My DB is e-commerce adoption. But you must notice something here. E-commerce adoption only have 4 statements. 1, 2, 3, and 4. So in that case, you will only add 4 and divide by 4, not divide by 5. Okay, divide by 4 because there are only 4 statements. So same stuff, complete variable, reset, go to adoption. This is your new variable now. Put the bracket in, adoption 1 plus adoption 2 plus adoption 3 plus adoption 4 divide by 4. Okay, remember divide by 4 because there are only 4 statements here. Okay. Right, so you can see now your adoption is also there. So basically now you already have your all the computed variables for your IB and your DB. Okay, so now you are ready to do the normality test. So let's see how to do the normality test. You can go to Analyze, Descriptive Statistics, and Descriptives. Okay, and once you selected the variables, you can choose Distribution, Kurtosis, and Skewness. So let me show this to you live. Go to Analyze, Descriptive Statistics, Descriptives, and then now you go and look for the variables. So I have knowledge, risk perception, trust, and adoption, and choose options. And this is what we call normality test, which is the kurtosis and skewness. It's the measure that we use to check for normality. So just select these two, continue, and OK. And you will see that the result comes out here. And the result will show you skewness statistics and kurtosis statistics. So how do we interpret these two statistics? Is here in this slide. Let me show you. So once you get the result, this is how you analyze the result. So the result here shows for all the variables, the skewness and kurtosis. So to confirm that your variables are not outside of normal distribution, we will look for skewness and kurtosis statistics to be within plus minus 2. Okay, plus minus 2. Within plus minus 2. So if they are within plus minus 2, that means you already passed the first test, which is your data is normally distributed. Okay, so that is the first important step that you will do when you do your analysis. Are we good? Looks like everybody good, huh? All clear. So that means you already completed your first part now, okay, which is this one. Normality test is already done. Now we go into the second one, third one, which is called reliability test. So I proceed. If there's any questions, please interrupt me on your microphone and speak up. If not, I will proceed. Okay, now we are doing. Okay, yes, Wan-Ning. So what if the normality test fails? Okay, good question. If your normality test fails, it means that your data is not reliable. It's not consistently measuring what it should measure. And then you have a problem actually. You can't actually use the items in your variable to measure your total variable. So there are a few things that you can do that people recommend. Let's say your normality fails for one of the variable. You can then check which item is it that makes it fail. You can do a normality test individually for each items like this. Show you analyze, descriptive. Okay, I reset. Let's say your knowledge, the normality test fails. You can actually go into each of your normality here and then do a normality test here to see whether there is any one of the individual one that is actually the reason why it is failing. Maybe there is one variable here that is totally outlier. It is too out. And because of that, the normality failed. So then you can remove this item. You don't use this particular variable before you calculate the total average. The other technique that we can use is also called the outlier, removing the outliers. Okay, removing outliers, there is a method to do it. We usually use a box plot. So what does that outlier means is maybe some of your questions, some respondents, maybe one or two respondents choose everything 6. Now, everybody choose on the average 2 to 3, but suddenly there is 1 or 2 people, everything he put 6. So that could be the reason why your data shows that it's not normal because of these outliers. So there are certain techniques that you can use to remove outliers, and one of it is a box plot. One of it is a box plot to see where is your outlier. What you can do is to check whether there is any data that is too far out from your distribution. You can also manually check this by looking into your data. For example, each of these data to see if there's anybody who, from the rows here, right? You can see from the rows here if any of your respondents simply choose all 1 or simply choose all 6. Okay, if you have too many like that, that could be the reason why your normality is normally distributed. So if you find 1 or 2 respondents like that, simply choose all 1 or 2, you can remove those respondents. Just right click and delete the case. Right? You can delete the entire respondent or exclude the data. You can go to view, edit. There is a way you can exclude that particular data. Right? Let me see if I can find it. Okay, you can't do that. You can clear, right? You can click clear, so the entire case will be removed. Then you save the data as, right? Because if that could be the reason why there is an outlier. Okay, Wan Ying? Yes, that's why we should collect more than needed, so that in case there are people who simply tick, you can remove them. Okay, good. So let's proceed. Thanks for the question, Wan Ying. Very good question. Yeah. So next, we want to do reliability analysis. So reliability analysis, how we do it is basically we go to analyze, scale, and choose reliability. Okay, analyze, scale, reliability. So let me show it to you live. Go to analyze, scale, reliability, and then you choose all the variables in an item, all the items in a variable, sorry. Okay, just select. You don't have to do anything here. The model is automatically alpha. You can choose statistics if you want, but even if you don't put anything, automatically it will give you the descriptives. You can put item and scale. These two is already enough. Okay, continue. Okay. Okay, so it will give you the Cronbach alpha. This is the value that we are looking for. So how do we interpret this? Let me explain. So once you have done the reliability, you will get this data. Okay, so you will report this in your chapter 4. For Cronbach alpha, more than 0.7 is generally considered reliable. So that's the number that you want to achieve. And you have to do this for all your variables. So if you have 3 IV, you have to do 3 plus 1 dV. So if you have 4 IV and 1 dV, then you have to do it 5 times. If you have 6 IV and 1 dV, you have to do it 7 times. For all your IVs and dVs, you will do reliability. Okay, so you just keep doing for all your variables. Is this okay? Reliability analysis? It's easy actually, not difficult. Reliability analysis is very straightforward. The only problem is that if you find not reliable, okay, then again the same issue. You have to check whether there's anybody simply keying in. But if you, that's why I do the normality test first. If you pass the normality test, it's usually not difficult to get your reliability correct. Okay. So are we good? Everybody seems to be very focused. All right, good. Sleepy, huh? All right, I understand. Friday night. Tell me about it, huh? Okay, good. So let's then quickly do our 4, 5, and 6 very fast actually, because usually the first part is the one that you need more time. Huh? But by now, if you play with SPSS, you will feel that it's actually a very friendly software. You can do a lot of stuff. After a while, you can do things very fast. Okay? So I've also taught students before, and then within a few months, I see them working on it very, very fast, faster than me. So, it's just a matter of getting used to it. Okay, so let's do our third one. Our next test is test for association. This is basically hypothesis testing. So previously we are just doing descriptive statistics. Now we are doing hypothesis testing. We are going to do correlation, which is to check whether there is any correlation between IV and DV. So how do we do that? We go to analyze, correlate, bivariate. We go to SPSS analyze, choose correlate and bivariate. So let me show this to you live. Analyze, correlate, correlate, bivariate, And then I'm going to choose knowledge, risk, trust, because these are my three IVs, and then I choose my DV. Okay, so you can maintain this as Pearson. You can choose one tail if, because we are all having a directional hypothesis, one tail. And then usually I don't select anything from here. If you want, you can choose mean and standard deviation, but usually I don't, because you just want to see the correlation, Pearson correlation, and click OK. Okay, so there you are. This is your result, and this is actually already good enough to test your hypothesis. For example, let's say your H1 is there is a positive correlation between knowledge and e-commerce adoption. So now you already have the data here, knowledge, e-commerce adoption, risk, e-commerce adoption. So this is what we call a mirror table. It's actually mirroring because everything appearing two times. So you can choose to just look at one side. Just look at the DV and then look at IV and DV, IV and DV, IV and DV. So I illustrate this to you here. It's easier for you to see. Like this. Once you have the data, just look at the last column and you have three values here. First one is the correlation value. It shows the strength of the correlation. Okay, so, and the second one is the p-value. The p-value must be below 0.05, then only this correlation is meaningful or supported. And then the last one is just the number of respondents. Okay, and you can interpret this correlation value based on how strong it is. So of course, the higher it is, the stronger it is. Okay, so 5 is very strong, right? If it is 2, 3, 1 is very weak. If it is 7, 8, 9, then it's very strong, very high. Okay, there is also a chart for this you can easily find online to check the strength of the correlation. So you can see here, this is knowledge is the highest one, correlation. Risk is actually low correlation, but also still significant because below 0.05. And trust is also significant correlation. Okay. So that's how you interpret your correlation value. Okay, good. So let's see, we have already done correlation as well now. Okay, important thing is it's not so difficult. You see, now you feel we took so long to do this. One day, we did half an hour to this. Then to do this is only like 5 minutes. To do this is just 2 minutes. You see, so the advanced analysis is not very difficult, but the difficult bit is interpreting it. So that's why I've given you this information, how to interpret. So keep my slides. You all have my slide, keep this slide. It will be useful for you next semester when you're interpreting your findings. Okay, how do you interpret your findings? So you can refer to this as an example. Okay, so next one is, I want to show you how to do linear regression. Okay, multiple linear regression. So regression is a causal analysis. Correlation is just to see whether two things are correlated, but it doesn't say X causes Y. So you all remember this chapter I did with you, correlation versus causation. But regression is a test that sees whether X is the cause of Y. X makes Y happen. So it's actually a more powerful test. It's a causal test. So we call it MLR, or multiple linear regression. So I want to show you how to do this. This is also something that you can use to test your hypothesis. So you have your data, you go to analyze, regression, and linear regression. Analyze, regression, linear regression. Then choose your dependent variable, DV, and choose your independent variable. Okay, and then you click done. So let me show you this live. Analyze, regression, linear. Choose your dependent variable, adoption, and independent variables. Okay, that's it. And then click OK. So now you already have the model, all right? So you have your regression value, the R square, you have the ANOVA table that shows you the significance of the model, and then it gives you all the result for all your IVs and DVs. Okay, all your IVs are here, and then based on this significance level, you can confirm whether they are significant or not significant. Okay, in impacting the DV, right? Causing the DV to happen. So we saw just now in correlation, they are all significant. So correlation is easy to prove, but regression is tougher. So in regression, only knowledge seems to be significant. The other two doesn't seem to be significant from here. Okay, so how do we interpret this finding? That's more important. So I've given you some interpretation here. This is how you interpret. So the R square is the percentage of the variance or variation in DV that is explained by IV. So that means all these three IV explains 30% of e-commerce adoption. That means knowledge, risk, and trust can only explain 30% of why people adopt e-commerce. That means there are 70% that we don't know why people adopt e-commerce. That's the meaning. 0.305 actually means 30%, 30.5%. This one is model fit. If it is not less than 0.05, all these result it cannot be used, right? Because this is signifying that there is this fitting model to predict the DV. And then the p-value here indicates whether individually they have influence on DV. So in this case, only knowledge have influence on DV because the p-value is below 0.05. The SIG in SPSS is the p-value. Risk and trust is not significant. So if you have three hypotheses here, you will say that only H1 is supported, H2 and 3 is not supported based on this result. Okay? Everybody good? Good, huh? So that's it. We already done our fifth analysis as well, multiple linear regression. So, of course, you may not actually see this happening live right now because this is not your data. This is just another student's work. But once you have your own data, you can try all these 6 analyses with your own data. Okay, so if you do until 1, 2, 3, 4, 5, it's actually enough already for your FIP. Right? Normally, FIP students will just do 1, 2, 3, 4 or until 5. Multiple linear regression is actually more than enough for your FIP analysis. But I just have one more extra in case any of you want to have what we call hypothesis to test difference between groups. So here is where we can use a t-test. Okay, a t-test is to determine whether there is any selected group have differences in a particular continuous variable. For example, you want to see whether male and female differ in their e-commerce adoption. Or you want to see whether male and female respondents differ in their risk perception. And let's say that is one of your hypotheses. So then you can use this test for difference. Okay, so I can demonstrate to you how to do this. This is optional. Some of you may have this such hypothesis. Some of you, most of you will not. But I just want to show you so at least you know there is such an option for analysis. So how do you do this? You go to, so let's say on this one, is there a gender effect on internet usage frequency? So you can actually go to analyze, compare means, independent sample t-test. We want to check gender and internet usage frequency. So let me do this live. Analyze, compare means, independent sample t-test. And the grouping variable is gender. So here I have to define the group. Remember to define the group, we have 1 and 2, right? 1 is for female, 2 is for male. That's how we define in our values. Continue. And then the test variable is now we want to see whether there is any difference in internet usage rate. How often you use the internet? Is there any difference? Okay, so I just click OK, and you can see the result comes out. The result shows that the male's mean is 1.68, female's mean is 1.81. So it looks like the female's mean is higher than male's mean. Okay, but before you jump to any conclusion, you have to first check what this mean mean. What is the meaning of 1? Okay, so how often you use the internet? So let's go to how often you use the internet, this question, and check what is their values. So go to variable view, how often you use the internet, how often you use the internet, and check on these values. What do you see on these values? 1 means daily, 2 means several times a week, 3 is bi-weekly, weekly, hardly at all. That means smaller means more internet usage. Bigger mean means less internet usage. So smaller means daily, right? So that means smaller means more. Bigger number means less. So now you go back to here. So now if you go to this number, you know that how often is your internet? The smaller number means more. That means 1.68 is actually more than 1.81. Okay, that's what the mean shows. And then, but you can't determine just from the mean, you have to look at the p-value. Remember in SPSS, p-value is SIG. So if the p-value is less than 0.05, then only this difference is significant. If not, the male and female do not differ in their use of internet. If this is below 0.05, then there is a significant difference between male and female. So you will conclude, so in this case, you will conclude from the result, from this result, the result actually shows not significant because it is more than 0.05. Okay. So let's say you have a hypothesis that says male respondents use internet more than female respondents. But with this result, the hypothesis will not be supported. You will say this hypothesis is not proven because the data shows there is no significant difference. The p-value is more than 0.05, although the mean shows that the mean for male is actually higher than female, but this difference in the mean is not statistically significant. That's how you will conclude your finding. Okay, so with that, we are already done with the second part of our analysis, which is the test for difference. So if you do up to 4, you already pass your FIP. If you do until 5, you're doing very well. If you do 6, this is additional if any of you want to do some extra analysis. So you can play with it, experiment. You have all this sample to work with. You have the data. So don't let this stop here. This is only an exposure for you to play with SPSS. You know now what SPSS can do. So what you have to do is learn more, try more, and you can even YouTube some extra analysis if you want and explore other possibilities that you have in SPSS. It's a very powerful software that can do a lot of things for you. Just keep trying out with your own data, and then I'm sure you will begin to like it. Okay, so in the meantime, any questions for SPSS? Are we good? All right, so if there's no questions from SPSS, I just want to tell you a little bit about your submission for your project. This is our last class already. We have completed everything. I'm still marking your midterm take-home assignment. You will get to know the marks later, but don't worry about that. What you should be focusing on now is your final project, which is this one. Okay, so your final project is due on the 9th of October, remember? 9th of October before 5 o'clock. And what do you have to submit? This is what you will be submitting. So you need to generate Turnitin originality report, or your supervisor can do it for you. Check with your supervisor. Similarity of this report must not exceed 20% for your chapter 1, 2, and 3. So that means when you do the Turnitin, only do for chapter 1 until chapter 3. Don't have the preliminary pages and references page. Only the content of chapter 1 until chapter 3 must not exceed 20%. Okay, so your supervisor will assist you to do this. And then submit one soft copy report plus the Turnitin originality report and at least 5 copies of the meeting record form, which is in your MMLS you can get, to your supervisor via email. Because we are not meeting face-to-face. So all this is to email to your supervisor. But what is it that you submit to me? You will upload the soft copy of the Turnitin originality report in PDF format to the assignment page of our subject. Okay, so this is very, very important. You will upload the soft copy of the Turnitin originality report, which means your chapter 1, 2, and 3, after submitting into SPSS, it will give you the full Turnitin report. That report in PDF it will always be in PDF lah. It's the one that you will upload into the our MMLS, which is here. Okay, you will go to MMLS, you go to assignment. Okay, it's already in MMLS. You can see research report. Chapter 1, 2, and 3 is due in week 14, which is 9th of October. Okay, so you will submit the report here. Okay, submit the report here. What is it that you submit? Again, what will you be submitting? You will be submitting the Turnitin originality report. You will be submitting Turnitin originality report of your complete chapter 1, 2, and 3 in PDF format. Okay, so this is compulsory because any report that is not submitted in MMLS means there is no record of you submitting your project, which means there is no marks for you awarded for this component, which is 70%. Although you submit it to your supervisor and your supervisor marks it and give me the mark, but if there is no proof that you submitted it to the subject, remember the marks comes from the subject. Okay, this subject is the one that will enter the marks for you in CAMSIS. So it has to be uploaded into MMLS as a proof that you have completed your work. Okay, so the day that you are looking at is 9th of October. And what are you submitting? Complete Turnitin originality report in PDF format of your chapter 1, 2, and 3. Okay, so I hope this is clear and everybody is progressing fine. By now you should already have completed chapter 1 and 2, and some of you should be now completing your chapter 3. Your chapter 3 should all be done latest by next week, and you should already be completing everything by next Friday, so that your supervisor have enough time to generate the Turnitin report and then for you to do the corrections after the report. Okay, so any further questions, boys and girls? Basically, this is our last class. We have completed everything. I don't think we need any other sessions. Let me see if at all I have any announcements for you. Please keep checking your MMLS. If I would like to meet you again, maybe in week 14 or something, I will organize and I will inform you if there is a need. Otherwise, please independently work on your chapter 1, 2, and 3, because that is the most important submission for you for this subject to get your 70%. And I hope you are closely working with your supervisor as well. Right. So that's about all. I will stop presenting. Any questions for now? No, so I will stop the recording.